So today we shall discuss with the control system lab experiment, that is the lag compensation network. So what the aim is to plot magnitude and phase angle characteristic versus frequency of lag compensator. I will just explain the procedure how to do the lag compensation network. Okay, so what will be there in the front panel of the kit? So mains will be there, frequency will be there, amplitude, output, phase angle frequency meter, phase angle or frequency meter, that is LCD display, indicate phase angle difference and also the frequency of the signal, and reference in, that is nothing but reference input to measure phase angle difference and frequency. And the next is phase shift. Okay, phase shift input to measure phase angle difference. Next, network R1, R2, that is resistors, capacitor, and peak voltage in and out, that is voltage input and the output. Now we shall come to the main circuit, that is lag compensation circuit. So the connections are like this. You can observe. So when you observe the lag compensation circuit, first we need to do the connection, that is from output to reference in. Okay, and from reference in to, that is R1 will have a two connections. Okay, so first for example this we shall take 1 and this is 2. Okay, so for first terminal we have connected, from second terminal we need to connect to phase shift in. Okay, and from second terminal to again capacitor, and from this is 1 and this is 2. Okay, and the capacitor terminal 1 is connected to ground. Okay, so this is the connection for lag compensation. So whatever the dotted lines is there, that you need to do the connection. So whatever the dotted lines are there, that is the connections. Okay, so now we shall see the procedure. So how we need to take these readings. What is tabular column? They have given V in and frequency, phase angle, output voltage and gain we need to find out after taking the readings. Okay, so first they have given peak voltage. There one knob will be there, input voltage and the output voltage. If we make upside, or if we make to the knob to the upside, that is a input voltage. Okay, so input voltage, by varying the amplitude we need to set the input voltage. So switch on the main supply to the unit, observe the sine wave signal by varying frequency and amplitude potentiometer. So now make the network connections as per the circuit diagram. Note down the peak detector input signal using digital voltmeter provided. Now the frequency, and note down the frequency, phase angle difference and output voltage peak for different frequencies, and enter the readings in the tabular column. So first we need to set the input voltage here. Before we take the readings of this, first we need to set the input voltage as, here we will consider the 3. Okay, input voltage as 3. After setting a input voltage, how we will set the input voltage means by varying the amplitude. Okay, first we will set the 3 voltage input voltage. After setting that, knob we will make down. Okay, that is V out. So V in is upside and V down is down. Okay, so now after changing the knob to V out, next we need not to change the amplitude. Okay, after that we need to change the only frequency. Okay, so after setting the input voltage, don't vary this amplitude. Okay, don't touch that amplitude knob. Okay, so we have already set the input voltage. Now you should vary only the frequency part, that is this one. Okay, this knob you need to vary. So from frequency, for different varying frequency knob, you need to take the readings of phase angle and the output voltage. So the output voltage will be here, and the phase angle difference and the frequency will be here. Okay, so here you'll get the frequency and also the phase angle. Here the voltage will be visible. Okay, so you need to note down the three parameters: frequency, phase angle, output voltage. Next you need to calculate gain equals to 20 log V out divided by V in. So V in is what we said before. Okay, so that is a 3 voltage what we set by varying a amplitude, that is the V in. V out is this one. Okay, this is a V out what we consider for different frequencies. Okay, so after writing this, you need to do a graph. Okay, so this is the experiment. Plot the graph of phase angle versus frequency. So you need to draw the graph phase angle versus frequency and gain versus frequency. Okay, so one is phase angle plot and another one is magnitude plot. So this is repeated for the same for the different frequencies. Okay, here in the procedure they have not observed the sine wave signal by weighing frequency and amplitude potentiometer. Now make the networks as per the connection circuit diagram. Now note down the peak detector input is using a digital voltmeter provided. So they have said that note down the peak detector, but you need to set the input voltage, then you need to vary the frequency, and then you need to note down the phase angle and output voltage, and also the frequency you need to vary, and phase angle, output voltage. Okay, these three readings are important. And next you need to calculate the gain, that is 20 log V out divided by V in. Next you need to plot phase angle versus frequency and gain versus frequency. Okay, in next class we shall discuss with the other experiment.